So hello guys, I am Jeff and I want to share to you about a certain theorem that we encounter since high school. However, this theorem is a very essential theorem, especially in engineering subjects like in physics, mechanics, and many other subjects. This theorem is very common but very essential. This is the Pythagorean Theorem. So I want to share to you how to prove the Pythagorean Theorem. Actually, there are many ways to prove this theorem. However, now I want to share how to prove it through figures. Actually, according to Pythagorean Theorem, in any right triangle, the sum of the squares of the two perpendicular sides is equal to the square of the other sides. So let us study about this one by one and prove about this. So let me draw a right triangle. So let us say there is a right triangle with sides 300, 400, and 500 millimeters. Okay? So let me change the colors so that we can see distinction with the sides. So according to the theorem, the sum of the squares of the two sides which are perpendicular to each other is equal to the square of this side, which is the hypotenuse. So let us prove this fact. So first, let us square all the sides one by one. First, let us square this side. We know this side is what? 300 millimeters. So, offset of 300 and connecting the line, we can attain the square of this side. And how about this side? This side has a length of 400 millimeters. So let me show you the square of this side. So offset of 400. And connecting the lines shows the square of this side. And how about this line or this side? This side has the length of 500 millimeters. 300, 400, and 500, which is a right triangle. So, offset distance of 500 in connecting the points. This shows, sorry, this shows the square of the hypotenuse of the right triangle. So, according to the theorem, the sum of the square of these two sides, which are these two squares, is equal to the square of this side, which is this square. So let us prove this fact one by one. So let me copy these squares. Let me deselect these lines. According to the theorem, this square, which is the square of this side, plus this square, which is the square of this side, is equal to this square, which is the square of the side, the hypotenuse of the right triangle. So let us prove this fact one by one. When we look only at the figure, it seems not right. However, when we try to inscribe these two squares into this larger square, we can prove that they exactly fit the largest square. So first, let me make this square a right square, right rectangle. Reference. Oops. According to the theorem, d square plus d square is equal to d square. First, let me inscribe the square into the largest square. And how about this square? How can we inscribe this square into this largest square? So we have to divide this into smaller squares. So as we see, the remaining area has small dimension, which is this one. So actually, this blue square has a side of 400 millimeters. And this entire square has a length of or side of 500 millimeters. This means this side from this point to this point is 100 millimeter. So let's divide this small square into equal squares with a side of 100 millimeters. Mhm. So as we can see, when we divide the square into smaller squares with the side of 100 millimeters, it shows that there are 9 squares in this small square. Okay? So when we fit in these 9 squares into the remaining area, we can see that they exactly fit the largest square. Okay? So let me copy one of the square and count one by one. So one, two, three, four, five, six, seven, eight, and 9. So as we can see, exactly 9 smallest squares fit in the remaining area. So we can prove that the theorem that the square of these two perpendicular sides, which is this red square and this blue squares, is equal to the square of the other side which is the hypotenuse, which is this one. So now we have understood about this, and I hope you learned something, and I hope you enjoy. Thank you for watching.